Hey Team Bio, welcome to your screencast on nutrient cycling. So we've talked about energy flow through the ecosystem. You are familiar with the 10% trophic rule. And now we're going to talk a little bit about two different nutrient cycles. We're going to talk about water and carbon and how they cycle from abiotic reservoirs to biotic reservoirs, so non-living reservoirs and living reservoirs. The water cycle will probably be very much a review of something that you've already seen, and the carbon cycle might be a review and it might be a little bit new. So let's get right to it. Okay, so as you all know, water comes in three different states of matter. We have it as a gas, which is water vapor. Here is a gas. We have it as a liquid, which is water. And we have it as a solid, which is ice. And in the water cycle, water will be in any one of these three states of matter, and it will either be in an abiotic reservoir, meaning a non-living reservoir, for example, the ocean, or a living reservoir, like inside of a tree or inside of a person. Okay, so let's get right to it. Let's start, it's a cycle, so we could start anywhere, but let's start with the ocean. The ocean contains a lot of liquid water. Now, the ocean plus the input of energy from the sun means that the sun's electromagnetic radiation is going to strike the surface of the water, and this ocean is going to experience evaporation. Evaporation is when liquid water turns into a gas, water vapor, and it's going to rise. So this is ocean evaporation, and up in the air, we have a cloud. Clouds can form. A cloud forms when you have condensation. Condensation is when water turns in from a gas, that's water vapor, to a liquid, but a very tiny drop. Of water, or even a very tiny drop of ice. So these clouds are made up of these really small liquid droplets of water, which are so small that they can stay suspended in the atmosphere. But sometimes they coalesce into something slightly bigger, and we get precipitation. Oops. And precipitation can come in many different forms. It can be rain, it can be snow, it can be sleet, SL, which is kind of like a rain snow, or it could be hail, which is ice. But an important thing to notice about the water cycle around the ocean is that the amount of evaporation is greater than the amount of precipitation. So evaporation is larger than precipitation. Okay, so we get these clouds forming from evaporated ocean water, and wind is going to push them from over the ocean to over the land. So here we have another cloud. You can see here that the two arrows that are occurring over the ocean, maybe the precipitation over the ocean and the precipitation over the land, they are roughly the same. But the evaporation that's coming off of the land is much smaller than the evaporation that's coming off of the ocean. So I guess all this is to say is that there's a lot of evaporation coming off of the ocean, and that's where the majority of the water vapor in the air comes from. Okay, but let's label these again. So this is precipitation over the land, and once again, it can come in the form of rain, snow, sleet, or hail. So, oops. I think I can grab this and copy it, and oh, I don't know if it's going to let me paste. Haha. Sorry, you can't do that. You got to write it out again. Okay, so precipitation can be in any of these forms. And then this little arrow here is, again, it's evaporation. So when water that is in a lake, a pond, or a river, or a stream turns into water vapor, we have evaporation. But another piece of this arrow is called transpiration. And transpiration is the movement of water from roots to leaves to air through plants. So depending on where you are in the world, like if you're in the cloud forests of Borneo, for example, then transpiration is contributing a huge amount of water vapor that is in the air. If you're in a desert where there's not a lot of plant life and also just not a lot of water, then transpiration is a very small part of the water vapor that's in the air. Okay, so what else do we got here? Okay, so we got our precipitation. It's rain, snow, sleet, or hail. It's coming down, striking the earth, and it is sometimes being collected by watersheds, so areas. So any droplet of water that hits this mountain range on this side is going to flow down through the watershed into the area that drains in this basin, and then maybe down to our alpine lake here. The water is eventually, if it's going to a river, it's going to go back into the ocean. So here we have a river returning the water to the ocean, but the water can also percolate down into the ground, where we call it groundwater. And the groundwater can also seep back in through the ground, back to the ocean. So here we have water, both river and groundwater, flowing back to the ocean. And here, the cycle begins again. So, what's powering this whole system is energy of the sun, and it will continue to go unless the sun disappears. And with the absence of the sun, this would stop flowing. Okay, next, carbon dioxide. Okay, so abiotic reservoir of carbon dioxide is in the atmosphere. So we have CO2 in the atmosphere as a gas. And I looked this up today. The current amount of CO2 in the atmosphere is 417 ppm. And ppm stands for parts per million. So for every million air particles, 417 of them are CO2. So it's a relatively small portion of the atmosphere, but the amount of CO2 in the atmosphere is increasing all the time, mostly as we burn fossil fuels. More on that later. Okay, so we got a bunch of CO2 in the atmosphere. This is one of our abiotic reservoirs of carbon. Now, the way that carbon enters the biotic reservoir, so living things, is through the process of photosynthesis. Now, there are a couple different types of organisms that do photosynthesis. Obviously, you know that plants do photosynthesis. We have algae, which is not a plant, it's actually a protist, which does photosynthesis. And then there are also certain types of bacteria that do photosynthesis. For example, cyanobacteria. Cyano being blue. They're also called blue-green bacteria. Okay, so we have all these different types of organisms doing photosynthesis. And photosynthesis is the reaction that takes CO2 and, using the energy of the sun, smashes CO2 molecules together and makes sugar. So we take CO2, which is in the form of a gas, and we turn it into sugar, which is a solid. Photosynthesis requires sunlight in order to be performed. So we'll say it's a reaction that requires energy. And that energy is the sun. So we call it, because it requires energy, we call it endothermic. Okay. So this is the way that carbon dioxide gets incorporated into organic compounds. So CO2 becomes sugar through the process of photosynthesis. And it's the way that producers, these are all producers here, build their bodies. This plant is primarily made up of carbon. That carbon came from the air and it was turned into solid mass of the tree. Okay. The carbon, the sugar, is going to move from the level of the producers to the level of the consumers when it is eaten by something. So, for example, we have a primary consumer, a rabbit, which is, I guess, eating our grass here. So the rabbit eats the grass. The sugar that was in the grass now becomes sugar in the rabbit. And you know the 10% trophic rule is that some of that sugar will become the body of the rabbit, about 10%, and about 90% of that energy is actually going to be released as heat as the rabbit burns. So they show our heat arrow. As the rabbit burns that sugar. We're going to talk about what that name of that reaction is in just a second. Okay, in our first screencast, we talked about how we have this nutrient cycling where we talked about producers, consumers, and decomposers, and how the nutrients and energy were moving around those systems. And some of you, I think Nate asked the question about, on your screencast notes, about how not all consumers eat producers. You're totally right. We have a bunch of consumers that consume other consumers. So this is an example of a higher level consumer. A lynx is going to eat that rabbit, and then the sugar and the biomolecules that compose the rabbit are going to be passed on to the lynx, and some of that will become the body of the lynx, but 90% of that will be released, and the lynx will release heat as well as CO2. We'll talk about that in a second. So here we have higher level consumers. Okay, and they are also radiating out heat. But we're really concerned with keeping track of these blue arrows. And the blue arrows are showing us carbon moving from place to place. So we know that it came out of the air, it became the body of the tree in the form of sugar, and then those CO2 compounds were passed on to the rabbit, and then they were passed on to the lynx. Okay, before we get up to this part, number 3, I'm going to continue annotating down here, and then it's all come together in a second. Okay, not all plants are consumed by producers. Sometimes they just lose their leaves and the leaves fall to the ground. So we call that plant litter. This is the good kind of litter, leaf litter. And then also sometimes they die. So plant death means that the carbon that's in their bodies is going into the ground. The same is true of our primary consumers and our secondary consumers. Some of the carbon that's in their body will not be consumed, but it might go into the ground. If this rabbit were to die in a hole, then its body would go to the ground, so death would put this carbon into the ground, but also some of their waste, like their poop, contains carbon, and that would go into the ground as well. And this would become detritus. Detritus is a fancy word for, waste. It doesn't have to be carbon waste. You could have a lot of detritus in your room. Your room is very untidy. Okay, detritus here. Okay, so some of the carbon could end up in the soil, but a lot of the carbon ends up back in the atmosphere here. And all of these blue arrows connected from, so here we have an arrow you can see from this primary consumer, this rabbit. We have an arrow coming from the lynx, and we also have an arrow coming from a tree here. All of these arrows represent carbon going back into the atmosphere through this process called cellular respiration. Cellular respiration is a chemical reaction, much like photosynthesis. It involves sugar and CO2, but it's actually the opposite process, where we take sugar, we break it down into CO2, and in the process, we release energy. So this type of reaction is called exothermic because it releases heat. Okay, so cellular respiration is basically the undoing of photosynthesis. Right now, you are currently breathing. You're breathing in oxygen and you're breathing out CO2. The CO2 that you breathe out is produced during cellular respiration and it goes back into the atmosphere. So this is one way that we complete the cycle from the atmosphere into biotic reservoirs and then back into the atmosphere again. And all organisms do cellular respiration. Not everything does photosynthesis, but you can see here we have a producer, a tree, doing cellular respiration. Plants are constantly doing photosynthesis to store energy and then doing cellular respiration to release it and use it. Okay, but we need to follow this little pathway as well. Number 4. Okay, so this detritus, it can be broken down by soil microbes. And I don't know why this is a separate, oh, it's actually not a separate you can see here that the soil microbes are also doing cellular respiration. So they're part of this whole cycle of returning the carbon that is trapped in the sugar, returning it to the atmosphere as CO2. But there's one more pathway that's not really drawn on here, and I want to add it to the note. Okay, so do an arrow branching off of here, and then coming up to here. And then I'm going to add, sorry, I should have done this on your note before, but I didn't. I'm going to add another box here. This box is going to make it white. And then back here. So some of this former living matter, this detritus that's in the soil, can, over millions of years, high temperature and high pressure, become fossil fuels. Fossil fuels are primarily made up of ancient plants that have been pressed into coal, oil, or natural gas. But these fossil fuels were originally living things. And then these fossil fuels can re-enter the atmosphere. And I guess also, maybe let's do an arrow from this tree over here. So this is fossil fuels and wood. We can combust these fossil fuels or this wood through the process of burning or combustion, which is also an example of an exothermic reaction, releasing energy. So we burn these ancient carbon compounds or wood, the fresh carbon compounds, and we return the CO2 to the atmosphere. So some of it has been trapped in the ground for millions of years, and some of it has been trapped in a tree for maybe hundreds of years, but it returns to the atmosphere. And that's our whole cycle. Okay, that's all.